Alright guys, so here is a question that a couple of students have been asking from the homework. So the directions say to solve by the addition method, indicate whether the given system of linear equations has one solution, has no solution, or has an infinite number of solutions. If the solution has one solution, find the solution. So what you guys can't see is it's a multiple choice question. One solution with a box in parentheses, no solution, infinitely many. So what we're going to do, because it's got all these fractions, the first thing I need to do is clear those out so that I can set up for the addition method. So I need to find the LCD. So that goes back to the previous chapter. But if I'm finding the LCD, I'm looking for what's the least common denominator of all of these. Well, this first one, the only denominator is 5. So the least common denominator is going to be 5, and I'm going to multiply all terms on top by 5. And so when I go through and I simplify this, 5x times 5 is going to give me 25x. And then the next one, 4 over 5 times 5. Well, those 5s are going to cancel to 1. And then 1 times 4 is going to give me 4y. And then the last part, 2 times 5, is going to give me 10. So that's my first equation. Now that I've gone through and multiplied everything by the LCD. The second equation, the smallest thing that evenly divides, that the number evenly divides 3, 15, and 6 is 30. So the LCD of that is 30. So times 30, times 30, times 30. And then I'm just going to go through and cancel. 30 divided by 3 gives me 10. And let's actually write it. I'm going to write it up here. 10. 30 divided by 15 gives me 2. 30 divided by 6 gives me 5. So now I need to write this simplified. So in the first term, I have 10 times 10 times x. So that gives me 100x. And then the second term, 8 times 2 times y gives me 16y. And then 11 times 5 gives me 55. Now that I have gotten rid of all of those fractions, I found the LCD, I've gotten rid of the fractions, now it turns into a normal solve by addition method. So when I'm solving by the addition method, I need to get equal variables, equal in value, opposite signs. So I need to get what we call additive inverses. Well, if I look here at the x's, I could make these coefficients additive inverses by multiplying this top equation by -4. And just think ahead, if I multiply -4 times 25, that will give me -100x, which would then cancel out with the 100x. But I can't just multiply one term by -25, I have to multiply all the terms by -25. I have to multiply, sorry, not -25, -4 to get -5. I have to multiply both sides by the same number. So with this top equation, I'm going to rewrite it as -4 times -25 is, -4 times 25x is going to give me -100x. -4 times 4y is going to give me -16y. -4 times 10 is going to give me -40. Bottom equation's not changing, so I'm just going to keep that one the same. And then I can now add these down the components. So I can add -100 plus 100. Those are going to cancel and give me 0. Going down the next column, negative 16y plus 16y is going to give me 0. They'll cancel. And then the last one, negative 40 plus 55 is going to give me negative 15. And so what I'm left with is 0 plus 0, which is 0, equals negative 15. And that is not a true statement. And so because my variables have canceled out altogether and I was left with a false statement, my final answer is going to be no solution.